Right, hello. Today I'll be expanding on the already explained sine and cosine. If you watched my last video, you'll know that by only having the hypotenuse length and an angle length, you can solve for both of the upper sides in a right triangle. So, by using sine, we could deduce that if we knew the length of this angle, we could deduce both side lengths. But what if we only knew two of the side lengths and we were trying to solve for an angle? Let's break it down. What actually do we know about sine? We know that the hypotenuse of the angle multiplied by the sine of angle theta. Just so you know, that little symbol is not a zero. That is the Greek letter theta, and it is just often used in trigonometry to represent unknown angles, just like x is used for unknown numbers. And we know that is equal to the adjacent side length. Or not the adjacent, the opposite side length. I'm sorry about that. Which means that just by manipulating the numbers a little, dividing both sides by a hypotenuse length, we know that the sine of theta is equal to the opposite side over the hypotenuse length. And we can use this to solve for an angle. So I will delete this, redraw our triangle. Sorry it's so poorly drawn. So what we would do is, we would now know that the sine of theta is equal to 3 over 5, or 0.6. Decimals can get quite ugly. But what you want to do here is, you want to use what's called an inverse trig ratio. It's just like how you undo division with multiplication, you undo trig ratios with inverse trig ratios. Those being sine negative with the superscript -1 to represent that as inverse, and cosine with a superscript -1. Keep in mind, this does not mean, that is not an exponent. That is representing it as an inverse. This does not equal sine -1 does not equal 1 over sine. But that is not correct. Let's just make sure to remember that, and it should be all right. But yes, so just like with most sine things, you'll want to plug this into a calculator. I will pull up my calculator really quick. So 3 over 5, 3 divided by 5, and then sorry, give me a sec. 3 divided by 5. Sine -1. That gives us angle theta equals about 36.86. So 36.8. Yes, 36.8. I was showing about 36.8. And then, just like that, we can solve the entire triangle. Just subtract 36.8 from 90. So 90 minus 36.8. And you get this angle is 54.2. And then from there, you could either use the Pythagorean theorem or use the sine or cosine. For our sake, I will use the cosine. So once again, we already did this, but we know that 5 times the cosine of 36.8 is equal to this side, the adjacent side. So 36.8 sine times 5. That gets us about wait, I did sine. I'm sorry about that. I'm not thinking today. So 36.8 cosine. That gives us about 0.8, and 5 times 0.8 is equal to just about 4. What do you know? It aligns with the Pythagorean theorem proved 3, 4, 5 triangle. Thank you for watching, and once again, if there are any topics you would like to see further explored of this channel, leave a comment, let me know.